Hello everyone. Today we're going to do an interesting thing. I'll actually. Do you know us by the way? This is Ridwan, my son, right? High five. Okay. We are going to learn about how
Probability. We're going to learn about probability in like the tree.
The tree. It's a picture. It's a diagram. So it's a tree
Yeah.
diagram. Okay. But also in the process, we'll also learn this, and this is for parents and educators out there, right?
Yes.
We'll learn how to use YouTube to learn something, but also use digital boards. We have a digital board here, a digital board,
The pen.
the pen. I wonder what
The pen also works like a mouse, and there's also another mouse.
Right. So where is the camera thing? We gotta find out. Okay, there's the camera thing. So we have the camera, so that we can see if we're in the right place. Okay, fine. There you go. Okay.
These things are hard.
Yes, these things are hard, but these things are fun once we start doing it.
Yeah.
Okay.
So let's start it.
No, we didn't introduce Barney. Say hi, Barney. He's just gonna sit and watch, but we'll also talk to him sometimes, right?
You are weird, man.
Oh, he's weird. Barney's weird. He's trying to play a Rubik's Cube and watch us do probability. What's the probability that Barney's gonna solve the Rubik's Cube before we're done?
Probably 0 since he's a doll.
All right. Okay, so that's called what? What's the zero probability called?
Impossible.
Impossible probability. What's the opposite probability of an impossible probability?
Certain.
Certain probability. Okay, great. So now what are we going to do? We're going to play a YouTube video that shows how to draw a T diagram. It's a very basic one, but...
Why are you saying play a YouTube video? Are you gonna like play a game?
Don't talk.
Okay.
Okay. In this tree diagram, they showed examples of blue and red balls, but they didn't actually show blue and red balls. We have blue and red balls here. So
yeah, but they showed 7 blue balls, so we're using a substitute of green as blue.
Here, okay. And they show 3 red balls. So he's gonna show you how to, in the tree diagram, they're gonna show how to pick up this randomly. So we're putting this in the bag. And we'll also do random picks, okay?
Okay.
All right, here we go. Let's see what happens in the YouTube.
Hi, this is a probability question that we're going to solve using a tree diagram, but let's just read the question first. Jenny has a bag with 7 blue sweets and 3 red sweets in it.
As you can see, there is a problem in the YouTube that's showing that Jenny has a bag with 7 blue sweets and 3. No wonder they didn't use a bag, because the sweets would totally mess it up. Okay, we have balls that looks like sweets, right? All right.
Yep.
And then
places it and then picks again at random. Draw a tree diagram to represent this situation and use it to calculate the probabilities that she picks. A, 2 red sweets. B, no red sweets. C, at least 1 blue sweet. D, 1 sweet of each color.
all right, so we got the problem set up, right? What does the problem say, Ridwan? What does the problem say?
It says, what's the probability that Jenny will pick 2 red sweets?
No, start from the beginning. Describe the problem.
Okay, so Jenny has 7 blue, so 1.
So put the blues in there.
Yeah, so
Count
1, 2, 3. Oops.
Put them.
1, 2, 3, 4, 5, 6.
Okay.
Yeah.
Okay.
He's feeling sleepy, I'm guessing. 7. We don't have 7 blues, so we substitute with
And
green.
she has 3.
3 reds.
Okay, 3 reds. Now she's gonna pick a sweet at random from the bag. No color preferences, right? Then she places it back. Yeah.
Yes.
Okay. Then what? Then picks it again at random. Okay. Based on that, we'll draw a tree diagram following the YouTube to represent the situation. Have you seen a tree diagram before?
Yes, I have.
Where?
In American. Well, I saw some problems of it, and I saw it in Cyber Chase.
Tree diagram?
Yes.
How does it look?
How does it look? Well, it's practically, if you write 2, and then there's 1 connecting there, 1 connecting there, 1 and 1. And in the middle of them, plus. 1 plus 1 equals to 2, something like that.
That's something like that, it's true. And
so if you write 4, you can do 2, 2, 1, 1, 1, 1.
Okay, so you can show it here, right? Do you want to draw something like this?
Yeah, give it to me, please. Okay, so practically we have, yes, we have.
Oops, it went all the way there.
Okay.
You need to know how to use the digital pen. You may have to use it there or there, you don't know.
Okay, give it to me.
Just imagine. Oops.
Okay.
Right, okay.
Now I'm going to back, so.
It's gonna go back there.
Why?
That's how it's orientated.
Okay, so let me write 4.
No, this is gonna make people really bored. Okay? Really bored. No, this is not how you do it. It's wasting a lot of time. Okay? So you gotta go straight to the point. 2, you said, right? And this is what you said, right?
Yeah, 1.
1. And that means
It's not only like this. Write 4, please.
Write 4, okay.
Then these will be 2.
Oh, so this will be 2.
This will be 2.
2.
And now you can draw another one like this.
Over here.
Yes.
And then over here.
Yes, and these will be 1.
Okay, why do you think they're called tree diagrams?
Because they branch out like a tree.
Exactly.
Like one thing connects to another.
It's just like the branching of a tree. Great. Okay. Let's just adjust this a little bit. Okay, let's see. Let's carry on with this and see. So, how do you think they're going to start the tree diagram?
I think they're actually going to see, like, they're going to say there are 10 balls in total.
Okay.
7. Okay, so write down 10.
Write down 10.
Then give one of those like branches that I show you in tree diagram.
1 branch or 2 branches?
2 branch.
3 branch. 2 branch?
Yes.
Why are you deciding for 2 branches?
Because this will split up.
Why not 3?
Because there are only 2 objects.
2 objects? Like
no, like there are 10 objects.
Barney? 2 objects? Okay.
Okay, so practically there are 2 different kinds of objects.
2 different kinds of objects. That means you got 2 different kinds of options.
If you have if there was 10 like objects in total, but if there was something like maybe a green ball, 1 green ball, 3 red balls, 6 red balls. 6 blue balls. So then you could write 3 branches, and then you can write them separately.
Okay, makes sense. So let's see what the video says now. Okay, I don't know if that's true.
Just wait. You haven't written there 7 blue and 3 red and a plus.
Should we? Okay.
Yes. Let's see if that's what we get.
I'm not sure if they really did that. All right.
Well, let's start off by drawing our tree diagram. We'll look at the first pic first. There are 2 possibilities that she has. So we draw a sort of double branch like that. One represents her picking a blue sweet, the other one a red sweet. I'm using B and R to mean blue and red.
Something to learn. They didn't put numbers. What did they put? They put, because each of these blue, red, and these things, right? Blue, red, it's actually gonna it's actually representing what are you picking up. Are you picking up a blue? Because each time you're not picking up 2, you're just picking up 1 of them, right? So, want to pick up something?
1.
Yeah.
Blue.
Blue. Okay.
It's most likely that.
Right. Okay. Let's put it back. Okay. Let's carry on with the video and see what it does.
Now, what about the probabilities of that? Well, because there are 10 in all and 7 of them are blue, probability of a blue is 7/10.
Does it make sense?
Yes, because blue is actually more likely to be chosen.
Right, and what is the number that more likely thing is going to be?
Because there are 10 objects, then you divide 7 by 10 and see the probability of how much blue objects.
Okay, so let's do this. Let's get this thing out of here.
Let's draw a page.
No, let's just do it like what he's doing for now, okay?
Okay.
And see really, so you start off there, and either you pick a blue
or a red,
or you pick a red, okay? Now he's saying that the probability of picking this blue is 7/10. I want you to say this in English, really. Mathematically you say 7 divided by 10, 7/10. Tell Barney, tell Barney in English.
You are weird.
No, I'm not weird, really. Tell him, Barney, you see that? Blue pickup is, he's not going to understand 7 divided by 10. Just tell him in English, come on.
Practically.
Look at Barney. What do you think? He's not watching you? Very attentive student.
Okay.
Look, he's even putting his Rubik's Cube aside.
Okay, weirdo, I'm telling you. I'm telling Barney.
Look at him.
I'm telling Barney, okay, you weirdo. Okay, so practically, yes. So it means that we're making 10 slots, and we're putting parts of 7.
I know, it's still making it difficult, right? Why can't you just say that in English, like slots? I know, I don't understand it. Make it easier, come on.
Okay. So practically,
people are watching. They won't like it.
okay, how do you make it easier?
Alright, 7/10.
Yes.
How do you say that in English?
7/10.
Right. What are the other ways of saying that?
7 divided by 10.
That's math.
It's words. It's an English word. Okay, 7 to 10.
Math.
How?
7/10.
That's also math.
Out of 10 is math.
Yes it is.
The probability of selecting a blue ball
It's 7/10.
is because there are 10 objects in total. There are 7 blue balls. So all you can do is have a chance of selecting one blue ball.
Yes.
That's 7/10. There are
Yes.
10 different options that you have.
Yes.
And taking a blue ball, you have 7 options from there. So that's it. 7 options from 10 options. Now say it for the red ball.
Okay. So
Barney,
it's
you get that?
3.
Yeah. You got it.
Nah, I'm just kidding.
Okay. Tell him, come on. Don't waste
Okay,
time.
so it's 3 out of 10.
Yeah. What is that? What is that 3 out of 10 thing?
3 out of 10? It's 3 tenths.
Yes, say the full thing. What is the 3 out of 10? 3 out of 10 probability of selecting a red ball. That's how you should say it. Complete it.
Okay.
There are audiences out there watching us. They go 3 out of 10. What does he mean by 3 out of 10? What's that? 3 out of 10 dogs? No. 3 out of 10 red balls.
Candy.
Selecting 3 out of 10 red balls. Okay, let's move on.
Try.
No. Not trying now. We'll go on and see what he does.
Reasoning. Probability of red is 3/10. Now what about the second pick? Well, she has replaced whatever she picked first time, so we've got exactly the same situation in the bag as we started with.
So now we're going to redo it. Pick something, no looking. Aha! So the probability of this, that it got selected, is what?
3/10.
3/10, right. Now after selecting this at random, what did you do? What did Jenny do?
Put it back.
Put it back,
And
okay.
then select another one.
Wait, step by step. She put it back. She put it back. Right, don't fall asleep. Watch here. Alright, then what? She put it back. Okay, then what does that mean? To put it back and not put it back?
It means to like
say in terms of the total changes. If she puts it back, is there a change?
Yes.
What's the change if she puts it back?
Nothing.
Look what Barney says. No change! No change! Because she just put it back and it's the same thing! So when you put back something where you get it from, there's no change. You gotta think before you answer, okay? Barney, you're a very good student. Keep listening. Oh, come on! You can't do that.
But it's falling asleep!
Jealous boy. No. People watching.
Okay.
I know he's an audio student and you are. Okay, don't worry. Okay, let's keep on watching.
Okay, I won't do it anymore.
So she picks a blue first, then she's still got the same probabilities of picking a...
That's what it means. So when she put everything back, okay, and then starting from here, what is the probability that after she puts everything back, she gets gain 2 probabilities of picking it up? Okay, again 2 probabilities of picking it up here as well, right?
Of course.
Now from here where she starts is actually 7 out of 10, right?
Yes.
Can you say what's going to be here and here?
Well, this is going to be 3.
No. They can't see you if you put the finger.
Okay.
Use this.
Okay, so on the blue one, where you branched it out,
Mhm.
the bottom one would be 3/10.
This one?
Yes.
3/10. Why are you saying that? Is this going to be a red or a blue?
This is going to be a blue.
This is going to be a blue? 3 out of 10.
Red.
Yes, say what you mean. Okay, so this is a red and this is a
blue.
All right, so let's see what they did.
blue or a red second time. And if
so, it should be the same in here, right? 3 out of 10. Okay.
It should be the same on the down one as well.
What should be here? The number?
The number. It should be blue here.
Blue.
And this should be 7/10.
This should be 7/10.
And the red will be 3/10.
3 out of 10. Okay. Now, okay, let's carry on with this video.
he picks a red first, it's exactly the same again. So those are the probabilities for her tree diagram. We've just got 2 more columns to do. First of all, the outcome, and secondly, the probability calculations.
So look, what they did.
Well, the outcome.
What they did was also they said that this is the first pick. Then they put it back.
Yes.
Then this is the second pick. Okay.
Yes.
Second pick. Now, what that means is after taking a first pick, you put it back and you put the second pick. Then you are repeating things, right? The same way. But then the question would be, what in total the picks that you have in the first pick and the second pick, what were they together? So I'll give you an example. So for example, you pick this, oh, blue, okay?
Yeah.
Put it back and pick this, oh, blue again. So the probability of picking a blue and a blue in the first and second pick together,
Yes.
that's the probability that they're going to calculate.
So the same way, no, let me say if I...
See? More likely probabilities, right?
Okay,
so if you have this at the first pick,
yes.
put it back, take another one and this in the second pick,
Yes.
then together they make this.
Yes.
Now the question they had initially, remember, what is the probability of picking 2 blues, 2 reds, no blues, all those things?
Yeah.
That's what they're answering here. Okay? So they're now in the column of outcomes. So this is a column of the outcome. Outcome meaning how many. Not the probability. It's just how many they're getting. The first pick get a blue, second pick blue, blue, blue. In the first pick a red, second pick a red, red, red. Okay? So what they're trying to do is now show the outcome. Okay? And look where the outcome is written. The outcome is written around here. Okay? Why is it written here? Because, okay, by the way, what would be the outcome of the first pick and the second pick here? Do you know what would be the outcome?
The outcome of the first pick.
No. Outcome means you have already picked them up in the first pick, you picked them up in the second pick. Now we're talking about total outcomes. Okay?
Okay, there can be like blue, blue,
No,
blue, red.
So
red, blue,
tell me
red, blue.
Tell me what's going to be
Red,
here.
red. Here. Here's going to be blue, blue.
There. How do you know that?
Because on the first pick there's blue, on the second pick there's blue as well.
Very good. Here, what's going to be the outcome?
Blue, red. Because on the first pick there's blue, on the second pick there's red.
Blue, red. Here?
The difference here is you pick red first. So it's going to be red, blue first.
And then here?
Red, red.
Red, red. Oops. Red, red. Great. Okay. Now we have the outcome. Now up until here there's really no maths or probability calculation.
Yeah.
Okay? What now is going to happen is we're going to calculate the probability of having a blue blue. As you can see, there are blue
Probability of having a blue blue is very, very common.
We don't know that yet.
No, we do.
How do you know?
Because there's more blues than anything else.
Right.
So
from there we know. It's from the beginning we know. But if it has a first pick and a second pick.
Yes, but it's not certain.
But
It's like likely. It's likely to happen.
From here, can you say whose probability is the most? Just looking at this.
Probability is the most blue blue.
Just from looking at this?
Yes.
Looking at the outcomes here?
Yes.
Why is it? Why do you say looking at the outcomes it looks like more blues?
No, I said it looks more.
Are you saying 1 blue or 2 blues?
2 blues.
I don't see 2 blues many here. Do you see 2 blues many here?
No, I see blue blue.
That's what I mean, blue blue. Do you see many blue blues in the outcome?
No,
What do you see?
just 1 blue blue.
Then how can you say? How many outcomes are there, by the way?
There are 4.
Right. The 4 outcomes. Do you see out of the 4 outcomes more blue blue, more red red, or more blue red?
All of them have an equal chance.
Does the picture show that? These outcomes? Look at the outcomes. Look at the outcomes. How many outcomes?
Blue blue, only 1. Blue red, only 1. Red blue, only 1.
Is there a difference between blue red and red blue?
No, it's just that we pick red first and red blue.
Right? Okay.
And we pick blue first and blue red.
And this one is?
This one is red red.
Which one is more likely here?
Blue blue. Because, listen to me, because it's more likely to get blue. So if you get blue twice, which is likely to happen, it should be more likely. Because all of them are 1. If one of them was more than 1, let's say there was blue red and there was another blue red, it also had a chance. I don't know if it's bigger than that unless we calculate it.
Okay. Now let me ask you the question. What are these outcomes really?
These outcomes are really like if you randomly pick up a sweet.
Now you have a blue. Okay, I get it.
Okay, a blue. So we pick a blue,
Hmm.
and then if we pick a red, then it's going to be blue-red.
It's gonna be one of this.
Yes.
Right? Actually, this, because first you pick the blue, then you pick the red, right?
Hmm.
So now we have the blue-red. Just this way, how many outcomes are there?
There are 4 like this.
Out of these 4 outcomes, which do you see more happening?
None of them.
I see blue-red happening more. 2
But
times out of the 4 times.
why?
Yeah, I can say it. I can have a blue-blue, I can have a blue-red, I can have a blue-red again, I can have a red-red.
That's a red-blue.
Same thing as a blue-red.
No, it's not. It's that one. There's a difference. It's red picking up first, then blue picking up first.
Did you see the question here? What is the calculate the probabilities that she picks 2 red sweets? Here's the 2 red sweets. Calculate the probability that there's no red sweets. Here's there's no red sweets.
Yes.
So at least 1 blue sweets, at least 1 blue sweets here, and also at least 1 blue sweets here. 1 sweet of each color. 1 sweet of each color here. Okay? Okay. Alright. Let's see now.
No, you're not understanding me, I guess.
I am understanding.
No, like it's more likely to get blue. Let's see. So random, I'm close my eyes. There's red. Then I put it back. Then I close my eyes. I got blue. So I have red, blue. Now, let's say yes, I have blue. Then I have blue again.
Right.
So just like that, it's more common to get blue because it's more common that you will get a blue.
Okay.
So if you get blue twice, I'm not saying that you're not going to get this all the time. You're going to get this because there's blue inside of it already, but there's not a very good chance you'll get red.
Okay. Now let's look how they calculate this probabilities of getting blue blues, red blues, and etc. Okay.
Branch is blue and then blue to calculations. Well, the outcome of this first branch is blue and then blue, so I've labelled it BB. And the probability is 7/10 times 7/10 because it's blue and blue. And if you remember, when you're ANDing 2 things.
Can you guess why this will be?
Because you're multiplying blue by blue.
Why are you multiplying? Why are you not adding it?
No.
This is the probability. Why are you not adding 7, 10, and 7, 10? But why are you multiplying it? We didn't learn that.
Yes.
But can you guess?
Because the blue is multiplying with the blue. Blue.
This is not algebra. B times B. Then it's going to be B squared. Why are you multiplying 2 probabilities?
We're multiplying 2 probabilities because we want to get the answer. Because first of all, we have
How does multiplication work? Did you think about that?
Multiplication.
And why is not adding? Why is it multiplying? How does addition work? Because can also, someone who's learning this for the first time can say, oh, we get a first pick blue and a second pick blue. Why don't you just add the probability and say, okay, 7/10 plus 7/10. Yeah. But no, to calculate that the probability is going to be a blue, first pick, second pick together, replacing it back is multiplication. Why? Why not an addition? Then we got to think, how does multiplication work? Go to the basic question, remember?
So multiplication works like if you have 2 objects and you add them. Like you have 2 plus 2. What you can do is actually multiply 2 there instead of add it. Because multiplying that actually says that you're adding 2 of those objects.
Okay, fine. What else does multiplication mean? We haven't been discussing about the meanings of multiplication a lot of times now, right?
Yeah.
And that's why you're not really confident about it. Okay? How about this? Does multiplication have a relationship with division?
Yes.
Okay. So think about this. If you multiply 3 times 5,
Yes.
what does it actually mean?
It means you're adding 3 5s.
You're adding 3 5s.
No.
Yeah.
Yeah.
What else could it mean?
It could mean that there are 5 3s.
Right. So there are 5 3s or there are 3 5s.
Yes.
Right? Very good. Can you also say it this way? When you're saying 3 5s, so
Yes.
it's something like this. You got 5, 5, and 5. Can you say that for each of these three, there is a 5?
Like, can we say?
Like, not each of these 3. I said it wrong. I said it wrong. When there is 3 things, for each of those things 3 times, there is a 5.
For each of those things 3 times.
I mean, you have to go 3 times.
Yes.
But each time, there is a 5. Each time, there is a 5. And
Yes,
you can only go it 3 times that way.
Yes.
Right? Now do with a 3 something like
No,
this.
that's 3.
3, 3, 3, 3, 3, 3.
No, that's 6. 6 3s.
All right, 6 3s. So for each of these 3s, for each of those 5 steps, there is a 3.
Yes.
Right?
Yeah.
Now think about the probabilities here. This is interesting because now you'll know why they're multiplied and not added. When you have a chance of getting a blue 7 out of 10,
Yes.
right? That means you actually have this. You actually have 10 different options.
Yes.
For each of this,
7.
for each of, well, it's not really yet. So you have, out of this 10, I didn't know how many there are really. Out of this 10, let's say these are 7, okay?
Okay.
Now for each of these, you go 1, 2, 3, 4, 5, 6 here, 7 here, let's say, okay? Now, when you put them back,
Yes.
again, you're doing the same thing, right? So again, you're repeating it for each of those out of 10 things. Do you see what I'm saying?
Yeah.
So it's every time for out of 10, you're doing the same thing, just like you did something here with the 3 and 5. So 3 and 5 here. So that's why 3 times 5 and 5 times 3 always becomes the same. So, all right. How about thinking of it this way? If you add.
Yeah, I understood.
You understood?
Yeah.
That's why they're multiplied. And there's actually a common rule. That's like the logic of multiplication in probability. But there is a common rule that if you want to find the probability of something at the end of a branch of the tree diagram, if you want to get a probability here, then you always get to multiply along the branch like this, along the branch, here, along the branch. If you multiply the probabilities, then it will be the probability of this. In the same way, if you multiply, you want to get a probability of blue red, what should you do?
We should multiply 7 over 10
and
3 over 10.
And 3 over 10. And that's what they're going to do. Okay?
Try them
So
together.
just wait. Pause
That
for
gives
1
us 49
second.
over 100.
So practically 7 over 10. No, I mean, so blue red and red blue have the same chance of being
Because
so 50-50 chance for blue, red, and red, blue.
Exactly.
Because they're practically the same thing.
Right. Okay. That's a very good observation because that's what they're going to find out. Look.
The next branch is first blue, then red, BR for short.
We can write it 49%.
7/10 times 3/10, 2100. This branch here is first red, then blue, RB, 3/10 times 7/10, 2100, 2100ths. And the fourth one is two reds, first red, second red, 3/10 times 3/10, 900ths. Now,
So
it's always a good idea to do a check here.
So practically, what?
You can get this screen bigger now.
Okay, so practically, the blue balls are 40% more chance. There's 40% more chance you're gonna pick up a blue ball than you're gonna pick up a red one.
Because it's 49 and 9?
Yeah.
Yes, because this probability is being calculated out of 100. So basically, if you add all of them, which is going to do now, you will see that all of this percentage will add up to 100%.
Okay, I cannot. That's simple. Just wait. So 60, 70, it needs 30, which it got. Done.
Right? Yeah. So let's see how he does it.
Because all of these 4 probabilities add up to 1 because they're the only 4 possibilities in the situation. And they do add up to 100 over 100, which is 1. So we've done our check. Now let's look back at the question. We need to work out the probability that she picks 2 red sweets. Well, we've actually done that one. It's this
practically all
number here, 900ths.
So it's 9%, or 0.9.
Yeah.
There we are. Answer to that first part.
Mm,
Second part.
0.09.
No red
0.09.
sweets. Well, the only thing which has no red sweets in it is the blue-blue combination. And we've already calculated that. That's 4900ths. And so is that. Now we get a bit more complicated.
Now it's interesting. It said at least one blue. Which one?
At least one blue.
দেখো তো কত percent হবে এটা? Do you know how many percent that's gonna be?
One blue.
At
7 over 10.
At least one blue. 7 over 10. Where did you get that?
21 over 10.
21 over 10. At least one blue. At least one blue. You know there are many. Okay, so here's.
It's not.
Here's a combination you have. You got blue. You got blue red. You got red. Okay. And you also got another blue red actually. You know?
Yeah.
And these are the things. So at least one blue. Think about it.
So everything besides this. That's one.
What's beside this? Say the name. They can't.
Besides the red.
Yes, everything besides the red. But the rest, how do you calculate? What is that probability?
It's simple. Why don't we just add them?
Why don't you just add them? That's right, add them.
Yeah, that's gonna be simple. Look.
Why do you add them? Why don't you just
multiply it?
No, you won't multiply it. Come on. You have to add them. But what else can you do? How much does all of it make?
100.
Why don't you subtract it?
It's easier to do it this way. That's why.
It's easier to add it?
Yeah, just look.
Okay.
This plus this 60 because this is 70 because this is 60 and this is 10.
This is I understand this. Because the people who are watching us can see your this.
Okay. So 21 and 49. 20 plus 40 equals to 60. 9 plus 1 equals to 10, so 70. And then 70 plus 20 equals to 90 plus 1, 91.
Phone ringing. I'll just take it later. Okay. So what was the answer?
The answer was 91. 91 over 10. 91%.
We need to find at least one blue. So this has got a blue, this has got a blue, this has got a blue. There are 3 possibilities. And we get these by adding, because it's this or this or this. And if you remember, or in probability means add them together. So when we add those 3
together, those are the things we haven't learned about probability rules. If it's a or, multiple ors, add all the probabilities. If it's 49% or 21% or 21%,
then just add them all.
Okay, but these are rules that will come up later in probability lessons. Okay, we just started probability, remember?
Oh, yeah.
And the tree diagram is a good way to actually sense of how probability is working.
Yes.
Okay.
Together we'll get our answer. It's blue red, red blue, or blue blue. Adding them together we get that, which totals to 91 over 100.
The next question. You see the next question?
1 sweet of each color. Then it's practically just 21% plus 21%.
Wow.
So that's our answer.
But we forgot about Barney.
Barney!
Did you understand anything?
Barney, did you understand anything? Saying yes.
Just wait. Okay, let me do an annotation of him. Yes, I understood everything. I also understood that he's a naughty child.
Ah! No, you don't hit your fellow classmates.
Okay.
No, learning math is not everything in life. You gotta learn behaviors. Can you carry on? Viewers are watching, okay?
How the heck are you carrying this Rubik's Cube when you're like this?
But there is another slightly quicker way of doing it. Let's do that as well.
There's a slacker.
Now, the only one which doesn't have a blue in it is this one. And seeing as we've got all our possibilities adding up to 1, if we take this possibility away from 1, then everything else must have a blue in it, at least one blue. So our working is going to be 1 minus the possibility of 2 reds, which is 1 minus 9 hundredths, which is 91 hundredths. Same answer, no surprise it's the same answer, but it's just a different way of getting to it. Now what about the last one? 1 sweet of each colour. Well, that's just the 2 middle branches. First blue, then red, or first red, then blue. So it's this or this. So we add those 2 probabilities together. Blue red plus red blue, 21 hundredths plus 21 hundredths, 42 hundredths, which we may choose to simplify to 21 50ths. Just finishing off, let's look at our tree diagram again. Remember that as you go along a branch, you're doing one thing and another thing, so you multiply the probabilities. Each branch has multiplied probabilities. But when you're doing answering questions at the end, you might have to add these because you're doing this or this or this, etc., etc. So remember, multiply along the branches, but add the results of those multiplications to get your answers.
Did you get that? And also in probability, like they said, or is adding,
yes,
and is multiplying. Okay? Something that we'll learn later. Okay, I think that was a really good video on how to